Let's take a look at this example. What we're supposed to find first? We have to find for sure V1, okay? We have to find also R2, okay? So I'm going to start solving this problem from finding R2. Please notice that these two resistors are in parallel because the total current is going to split into two currents and is going to get back together at the other end of the circuit. Okay, so it makes these two resistors connected in parallel. So I have R total given and I have R1, so I'm supposed to use the formula called product over the sum to find R2. So if R total is equal R1 times R2 over R1 plus R2. Okay, so in order to find value of resistor R2, okay, I have to rearrange this formula. Okay, in order to rearrange this formula, I have to eliminate the fraction. If you want to eliminate the fraction, you have to multiply both sides of the formula by the denominator. So I'm going to have RT times R1 plus R2, this is equal R1 times R2. Next I have to distribute RT into the parentheses. Okay, so I'm going to have RT times R1 plus RT times R2, this is equal R1 times R2. I'm looking for R2. So all terms which contain R2, I'm going to move to the right side. So I have RT times R1 is equal R1 R2 minus RT times R2. Next, just copy down RT. R1 is equal, we're supposed to factorize R2. Okay, so I have R2 and I have R1 minus RT. Okay, in order to find R2, I have to divide both sides of my formula by the content of the parentheses, which is R1 minus RT. R1 minus RT. So this and this will cancel out, and I'm going to end up with R2 equals RT times R1 over R1 minus RT, where R total is equal 177.4. So I have 177.4 ohms times R1, which is equal 220 ohms, times 240 ohms, okay, 240 ohms, divide by, open parenthesis, R1 is 240 ohms minus R total, which is equal 177.4 ohms. So I have 177.4 ohms. Okay, this is equal. Now I'm going to use the calculator. Okay, so I have 177.4 times 240 equals, divide by, open parenthesis, 240 minus 177.4, close parenthesis. This is equal 680.12 ohms. 680.12 ohms. So we can say this is approximately 680 ohms. Okay, so this is the resistance R2. Next, I'm supposed to find the voltage source. Okay, please notice that at this moment resistor R2 has two pieces of information. It has resistance R2, which we just found, and has also power P2. Now we'll need to find the voltage. So we're going to use the formula for power, which contains the voltage. Power R2 is equal VR2 to the second power over R2. Okay, so this is the formula for power, which contains the voltage and resistance. Okay, so what we're supposed to do, we're supposed to solve this formula for voltage. Okay, so again I have fraction. In order to eliminate fraction, I have to multiply both sides equation of my fraction by the denominator. So let me do this over here. So I have to multiply left side by R2 and right side by R2. So I have P2 times R2 is equal VR2 to the second power times, divide by R2 times R2. R2 and R2 will cancel out, and we got this. We have VR2 to the second power is equal P2 times R2. In order to eliminate the square from here, we have to square root both sides of the equation, and I'm going to obtain VR2 is equal square root of P2 times R2. Okay, so this is equal square root, open parenthesis, P2 is given, and it is equal 120 milliwatts. So I have 120 milliwatts times R2, which is equal 680 ohms. So I have 680 ohms. Okay, so this is equal square root, open parenthesis, 120 exponent 3 negative times 680 close parenthesis equals 9.03. So this is 9.03 volts. So we can say approximately 9 volts. Okay, so my voltage source, okay, my V1 is equal to VR1. This is also equal to VR2. This is equal 9 volts. Keep in mind that in parallel circuit, the voltages across each component are the same. That's why I wrote that V1 is equal, VR1 is equal, VR2 is equal 9 volts. We found the voltage source and we find R2, so we can say that the problem is